Have you ever wondered what actually happens behind the scenes when you tap a button on an app or click a link? Well, today we're diving deep into the backend, that invisible, powerful engine that runs pretty much our entire digital world. We're going to trace the journey of a single click from your screen all the way to the cloud and back. It feels like magic, right? It's instantaneous. You tap your screen and boom, the page loads, the photo appears. But behind that one simple action is this incredible lightning-fast journey. So let's follow a single request and see what's really going on under the hood. At its very core, the internet is really just a conversation. Your browser, or your app, that's the client. It asks for something. It says, hey, can I see this web page? And somewhere out there in the world, a server, which is basically just a really powerful computer, is listening for that question and sends back an answer. So let's get our terms straight. You've probably heard of front end and back end. The front end is everything you can see and touch. The buttons, the text, the images. It's like the dashboard of a car. But the back end? That's the engine. It's the whole system under the hood that does all the real work, the heavy lifting, to make the car actually go. Okay, so let's start that journey. You just clicked a link. What is the very first thing that happens? How does your browser even know where to send its request across the entire vast internet? Well, first, your browser needs an address. You see, you typed in a name, like google.com. But computers don't speak in names. They speak in numbers. So it asks the DNS, the domain name system, which is basically the internet's giant phone book. The DNS looks up google.com and translates it into a numerical IP address. Now, with that number, your browser sends its request, but not just to the address, but to a specific port. Think of it like an apartment number in a huge building. This makes sure the request gets to the exact right application on that server. And that request is sent using a language, a protocol, called HTTP. It's the agreed-upon way for the client and server to talk. But you've definitely seen that S on the end, HTTPS. That S is a huge deal. It stands for secure. It means that whole conversation between you and the server is encrypted, scrambled up so that nobody can listen in. Super important. So, our request has safely arrived. It's at the server's front door. Now we get to see the real magic happen. We're heading into the engine room, where the request is actually processed and all the work gets done. Now, not all servers are built the same. A static server is pretty basic. You ask it for a file, it sends you that exact file. Simple. But a dynamic server, that's where things get interesting. A dynamic server can think. It can run logic, talk to other services, and build a custom response just for you. Think about your social media feed. That's built by a dynamic server. So how do you build one of these smart dynamic servers? Well, a super popular tool for the job is Node.js. Node was a game changer because it let developers use JavaScript, which used to just be for the front end in the browser, to build the back end too. One language to rule them all. You can think of Node.js as the workshop itself, the environment that gives JavaScript all its server-side superpowers. Now, if Node.js is the workshop, then Express.js is the awesome set of power tools and pre-built machinery inside it. Express is a framework that handles all the common, boring, and complicated parts of building a server. This frees up developers to focus on what makes their application unique, instead of reinventing the wheel every single time. Okay, so a request finally hits our new Express server. But wait, before it gets to our main application logic, it has to pass through a series of checkpoints first. And these are called middleware. The best way to think about middleware is like a line of security guards. Each function in the line gets to inspect the request. The first guard might just be a logger, writing down some info about the request. The next one might check for a security key. And the next one might unpack the data that was sent along. Each one does its job and then says, okay, you're good, and passes the request to the next guard in line until it finally reaches its destination. So our application can think, but what about remembering things? User profiles, products, posts, all that information has to live somewhere. It needs to be stored in an organized and safe place. And that brings us to the database. A really popular database these days is MongoDB, which is a NoSQL database. Now, unlike old-school databases that use rigid tables with rows and columns, MongoDB stores data in these flexible documents that look almost exactly like JSON. And why is that cool? Because it's super flexible. If you want to add a new piece of information to a user's profile later, you can just add it. You don't have to rebuild everything. So how does our server actually talk to the database? It uses something called an API.
And the standard language for these APIs is built around 4 simple actions we call CRUD: create, read, update, and delete. And this maps perfectly to those HTTP methods we saw earlier. You want to create data? You use a POST request. You want to read data? Use a GET request. Simple as that.
Okay, our app is getting pretty powerful. It can think, it can remember, but we can't just let anyone do anything they want. We need security. We need authentication. We need a virtual bouncer at the door. And here is the absolute #1 rule of backend security. You never, ever, ever store a user's password as plain text. It's a massive security risk. Instead, you use something called hashing. A tool like bcrypt takes the password and scrambles it into a super long, unrecognizable string of characters that can't be reversed. You only store that scrambled version. A really common and modern way to handle logins is with something called a JSON Web Token, or JWT. Here's how it works. When a user logs in correctly, the server gives them back a digitally signed token. It's like a special temporary ID badge. Then, for every other request they make, they just show that badge. The server can instantly check if the badge is valid without having to look up their password in the database every single time. It's way more efficient and super secure. All right, we have all the pieces of the puzzle: a server that can think, a database that can remember, and security to keep it all safe. Now, how do we organize all of this into a professional application that's easy to work on and get it ready for the world? To keep code from becoming a giant tangled mess, developers use design patterns. One of the most famous is MVC, Model, View, and Controller. Let's break it down. First up, the model. The model is all about the data. It defines the structure of your data, like what fields does a user have, and it's the only part of your code that's allowed to talk directly to the database.
Next up is the view. Pretty simple. The view is what the user actually sees. It's the user interface. Its only job is to display the data it's given. It shouldn't have any heavy logic in it. It just makes things look good.
And finally, the controller. The controller is the brains of the whole operation. It acts like a traffic cop. It gets the incoming request from the user, it goes and talks to the model to get or update data, and then it tells the view which information to display. This separation makes code so much cleaner and easier to manage. Okay, before we go live, just a couple more things. First, we use something called environment variables. This lets us keep sensitive stuff like database passwords or API keys completely separate from our code. And second, we have to set up CORS, cross-origin resource sharing. This is basically a security rule that gives our front end, which lives at one web address, permission to talk to our back end, which lives at a different one. It's absolutely crucial. And there you have it. We have followed a click all the way through a complete back-end system. What we've built here is called a monolith, where everything is in one single code base. But as apps get bigger and bigger, they're often broken down into smaller independent parts called microservices. Which kind of brings up a whole new question. As our digital world gets more complex, how are these back-end systems going to evolve to keep up? But that's a journey for another day.